Right, so question 10 of matter. State what is meant by a the nucleus of a particular atom has a nucleon number. So we'll write this down actually. A nucleon equals 14 and a proton number of 6. That must be carbon 14. That's meant to be a 6 there, sorry. State what is meant by a nucleon number and a proton number. I can't believe this is an A-level question. Nucleon, that is number of protons plus neutrons. I'm not going to write it out, you should know this. And proton number, well, it's the number of protons. Or the atomic number. I can't believe that's an actual A-level question, but never mind. Part 2, calculate the number of neutrons in the nucleus of this atom. So we've got, that's the number of nucleons, that's the number of protons. So the number of neutrons is 14 minus 6, 8 neutrons. Part 3, calculate the specific charge of the nucleus. Specific charge is the charge to mass ratio. So the charge of the nucleus is going to be 6 times the 6 protons, 1.6 times 10 to the minus 19, divided by the mass of the nucleus. There's 14 nucleons, so 14 times 1.65 times 10 to the power minus 27. I think it's 1.66 actually, but yeah, who cares? Plug it into your calculators, give it a shake and see what the number comes out. 4 times 10 raised to the power 7 coulombs per kilogram. Right. Part B. Specific charge of the nucleus of another isotope of an element is 4.8 times 10 to the 7. This is the specific charge, so coulombs per kilogram. Slightly different. What is meant by an isotope? So same proton number, different number of neutrons. Okay, and now we've got to calculate the number of neutrons in this isotope. I've run out of room here, so I'm just going to rub some of this out, and then we'll do the final part of this question. Okay. Right, so we've got specific charge of 4.8 times 10 to the 6. And this is part 2 now. We want to calculate the number of neutrons in the isotope. Well, specific charge is equal to the charge to mass. So to work out the number of neutrons, I'm going to work out the mass of this isotope, of this nucleus. So I'm going to rearrange this equation. I'm going to swap my mass and specific charge over. So mass equals charge over specific charge. And this will tell me the mass of the isotope. It won't tell me the number of neutrons yet, but I'll be able to work that out later. Right, so the charge, 6 protons, because it's 6 protons up here, times 1.6 times 10 raised to the power minus 19, divided by the specific charge, which we're given, 4.8 times 10 to the power 7. And that should be coulombs per kilogram. So I do that, and that gives me an answer of 2 times 10 to the power minus 26. That's in kilograms. That's the mass of the nucleus, approximately. If I want to work out the number of nucleons in there, number of protons and neutrons, I divide that by the average mass of a proton or neutron, 1.65 times 10 to the power minus 27. And that gives me 12.1-ish. Okay, so you can't have 0.1. I've obviously not been accurate enough. There should be 12 nucleons. The number of neutrons is going to be the number of nucleons take away my proton number. So it's 12 minus 6. There must be 6 neutrons in this isotope. Right, and that's it for 10.